Let's start into lesson 4.2. In last lesson, we talked about inverse sine and inverse cosine, and we restricted their domain so that they would pass the vertical line test and the horizontal line test. We're going to start today's lesson by doing the same thing with tangent and cotangent. So start with tangent. Here's our graph of tangent, you know that. The easiest way to restrict tangent's domain is just to keep one piece between those asymptotes. So that restricted domain would be from negative pi halves to pi halves, or quadrant 1 and negative quadrant 4 angles. So tangent is very, very similar to the sine restriction. And here's what that graph looks like when we take this graph and flip it on its side. This is the arctangent graph. Same thing with cotangent. We take, the easiest way to do it is just to take one cotangent section, which goes from 0 to pi. So quadrant 1 and quadrant 2 angles. Very similar to the cosine function, you'll notice. And here's when we flip that graph, this would be the graph of arccotangent. So graph of tangent, cotangent, graph of arctan and arccotan. Now, before we move on to our examples today, let's go in and add these domains into our table that we made last time. So if you remember, we made this table at the bottom of our 4.1 notes. Let's add in tangent and cotangent. So tangent, we just said, was negative pi halves to pi halves. And cotangent was 0 to pi. Very similar to sine and cosine. And let's look at the arctan and arccotan graphs. The domain of the arctan graph looks like it goes from negative infinity to positive infinity. And the domain of the arccotangent also goes from negative infinity to positive infinity. So there's our domains filled out so far. That will help us in today's notes. Excuse me. So now that we've talked about tangent and cotangent, let's practice finding them. So right now we're going to start pretty basic. We want arctan of root 3, just like we did in yesterday's lesson and last time. Set that equal to theta. So that means that is the same thing as tangent of theta equals root 3. So we are looking on the unit circle for where the tangent value is square root of 3. Now tangent's a little bit harder than sine or cosine, so a little reminder of a trick that we learned on the unit circle. The middle tangent value is 1. Go up, and that's root 3. Go down, and that's 1 over root 3. So that's one way you can remember the tangent values. So the square root of 3 is closer to the y-axis. The 1 over root 3, or sometimes we write it root 3 over 3, are the ones closer to the x-axis. And the 1 is right in the middle. And remember, cotangent will just be these values flipped. So now that we've got that reminder, it's pretty easy to see that that is the one we want, where tangent equals square root of 3. And there's one other place where tangent has a positive root 3 value, and that's going to be down here. Because those are the two quadrants where tangent is positive. You can also think of all students take calculus. Those are the two quadrants where tangent is positive. So what radians are these? Well, this one's going to be pi thirds. This one, is going to be 4 pi thirds. And now we think of tangent's domain restriction. Tangent was quadrant 1 and negative quadrant 4. So that means I do not want that one. The one I do want is pi thirds. That's the one that fits the restriction between quadrant 1 and negative quadrant 4 angles. So having done an example together, I want you to try this one. This one is a cotangent example. So remember that, take those values that we just talked about and flip them, and that will give you your cotangent values. And you're looking for where the cotangent is negative, what quadrants. Then pick the one that is in the quadrant restrictions for cotangent. So pause the video, try that out on your own, and then come back to check your work and see how you did. Let's check your work. So we have cotangent is negative root 3. That happens right here and right there. That's where cotangent is a negative root 3, which is at 5 pi 6 and 11 pi 6, or also note that's also negative pi 6. But cotangent is restricted in quadrant 1 and quadrant 2 from 0 to pi. So I don't want that one, which means 5 pi 6 will be my answer. Let's move on to C. In C, we've got those examples like we talked about last lesson, where we would think that the cotangent and the arccotangent are just going to cancel each other out because they're opposites. But remember, we talked about the one thing you have to check is negative 5 in the arccotangent domain. And here's where that table we filled out is going to come and going to be helpful. So we need to look at the arccotangent domain and make sure that negative 5 fits in it. So I come over here, my arccotangent domain is negative infinity to infinity. Negative 5 definitely fits in that. So that means I can come here and cancel those out and just get negative 5 as my answer. Now, same thing as we did last lesson. If this is the angle that doesn't fit, so if it's an angle and it doesn't fit in the domain, draw out your two triangles, pick the other triangle. If this is a point, so it goes with the arccotangent and it's not in the domain, then you say D and E. So one last problem. Let's do D, and then we'll end this video and we'll do the last two problems on our own video. And remember, for this one, like we talked about last lesson, we're going to use the inside as step 1 to build a right triangle. Then step 2, we'll use Pythagorean theorem to finish the right triangle. And then step 3, we'll use the outside to find our answer. So I'm going to say arctan of negative 3/4 equals theta. So tangent of theta equals negative 3/4. And I'm going to use that to build my triangle. So remember, tangent is y value over x value. So come over here. I want a y value of negative 3 and an x value of 4. Now remember, that could also be a y value of positive 3 and an x value of negative 4. So there's our two triangles that fit. However, this is arctan, so that means arctan is quadrant 1 and negative quadrant 4. So I don't want that one, so I want this one. Now step 2, use Pythagorean's theorem to finish the triangle. And you will probably notice this is just a 3, 4, 5, so we can finish it pretty quickly there. Then step 3, use the outside one to answer. So I want to end with sine. I know that sine is y over r. My y value is negative 3. My r value is 5. And you're done. So those are some examples of what we did yesterday, but using tangent and cotangent. In the last video, or in the next video for this lesson, we'll do those same problems we did yesterday where we use variables instead of numbers.